record this on. That's a good thing. Let me actually take a look at all the record. Okay. Let me go to my document. By the way, can you see my screen? You cannot. Okay. Okay. Let's go over the homework, right? So homework. This is homework. Homework 6 is 12. So let's actually do this. Let me reverse. Homework 6 is 12, but plus 4 point, right? It's because it has what the bonus point. And okay, that's you. Now you can go. Homework 5 is 10. Homework 5 is 10. Okay, Manuel, you know my math could be wrong as well, so let's try to work on the math. This is like our. This is like our. Okay, homework 4 is 8 point, right?
Yeah, but I didn't count the 4 bonus points from homework 6.
No, homework that's extra. That 4 point is extra. That's not that in the cutting. Okay, so the total point at this moment it could be 104. You totally potentially can get 104 if you get perfect. But I want to. I'm never pay attention to the detail about this number, but now is a good time for me to look at. Homework 3 is 10. So for example, I feel homework 10 should worth more. I mean, I really think that in terms of the effort you put in, I think homework 3 is a lot.
I agree.
Homework 2 is 10. And homework 1. Homework 1, I didn't say it, but I would just say is a warm-up. I give you 10 as well. Okay, it's really that 10% is really easy to get, but I'm still, because I didn't say it, its default is 10. Okay, so you can see that homework 1 to homework 6 without the bonus point is going to be 60 point, and then plus 4 point, which is the extra. Okay, and then that's the homework for 60%. And then we have the final is 20%, and then the SP is 20%. Okay, I mean this is a basic. I'm basically just adding up all your grading from each of the homework as well as the final program and SP, and based on that number, I'm going to see where you fit into this formula. Okay.
It says Canvas. It says that homework 1 was at a 6. So are you gonna update that or?
I will update that. In fact, when I submit the homework, I'm not going to use Canvas. I'm using separate. I mean, Canvas is sometimes it's just I don't know. I when I submit the homework, I didn't use Canvas. So I didn't use because I have to handle variety of things like a small program, extra credit, and incomplete is I have to do that separately. So I didn't use Canvas for my grading.
Okay.
So just to let you know, don't get a wrong impression about what Canvas show you on in terms of grading part. Okay.
But then could we also assume that if we got 6 out of 6 on Canvas for homework 1, that we're gonna get
that's
10
10.
out of
Yeah. If you got 6 out of 6 on Canvas, that's count as 10.
So Canvas is semi-reliable? Or
for the homework grade. I'm using Canvas for announcement. For announce that we have this, we have that, and or deadline. I mean, I'm not even use Canvas for homework submission. Submission is through hand in. So I'm not. Though I wouldn't call Canvas unreliable, but for homework 1, it's definitely unreliable.
Okay, I see.
Okay. Okay, so which means that if you haven't done homework 1, please do it. Okay, yes, go ahead.
So the cutoffs you showed us are just hypothetical, right? You're showing us how you would do it. They're not the real cutoffs.
Let me just, it is hypothetical, but this cut, let me get rid of this part. This cut I'm showing here, the cut can go lower, but not higher. You understand what I'm saying? So it means that if I put it here, if you got 88, it's guaranteed A. I'm not going to raise this tomorrow to 89, but I reserve the right to lower it to 87 because I haven't seen your final exam. I haven't seen your homework 6 because I have some, because for example, if final exam is really, this happened before. For example, whatever grade final exam is a bit rigorous and such that the grade is actually significantly lower. So we might actually adjust the grade, adjust the cut because of that, because I think that actually should work more in my scale. So this number is hypothetical in the sense that it can potentially go lower, but it cannot get higher. I want to set a bar here saying that if a student already did well, that and achieve certain percentage, it guaranteed to be that grade already.
Okay.
Does that answer your question?
Yeah.
Okay.
Also, could you give us like a timeline of homework 7?
I already have homework 7 running on my, I try to release this today. I will go to detail, but there is a few detail I'm trying to think about how to operate because some of the things that some of the students prefer to do it earlier before the end of the final so they can have other things to take care. So I'm actually going to have 2 different options for the student to exercise. That's why I'm still tweaking. Okay.
Okay, thank you.
You're welcome. And also on top of that question, Melissa and other students here, that I will provide also a video for homework 7 as well. So you're not just given a written things like the final exam, you will get extra information about how to do things. Okay. All right, let me take a look. Okay. Yeah, so homework 1, I will give you 10 points for that, okay? Sorry about that. I might have hit the wrong key. Our grade Ethan, what's the question means E? I mean, our actual grade isn't lower though, right? For the homework, I don't understand. Will homework 7 rely on homework 6? Yes, homework 7 will rely on homework 6. That is also partially I decide not to drop the lowest grade. I want to address Alexandria's question about homework 6 and homework 7. In fact, there is a dependency on the homework. So homework 6 rely on homework 5 and homework 3. So homework 7 really rely on homework 6 because we're going to build on top of that. What I might do is the following. For those of you who didn't have a reliable homework 6, is that I will provide the object file for the reference implementation, the real one, not the reference, I mean the complete one. So you can use the .o file to link to your own program to work on that. But I said equally, I will be really happy to help you to debug your homework 6 to get it to work, okay? 20 for the 20 small program, 20%. Jerry is 20. I will give 20. If you have 20, that's enough for that 20%. The current directory of the server. I'm actually replying to the question from Aldo. Aldo, the server directory or the client directory should have that. I think for you to verify with me about whether your VSID is done, for some of students, they just send me the VSID and I go to my small program log to see how much you have. And then I can just check whether it's, I mean, let me just show you what it looks like. I think it's okay to show people's VSID, okay? Hold on 1 second. Oh, okay, so this one is okay. So I have to, sorry about that. Let me actually update let me update this video very quickly and then I get back to you. Okay, so just want to tell you that wait a minute, everyone. That I just got this video release. Okay, so it's done. So just let you know regarding the video I talk about memory issue. Okay, so now I'm going to share the screen. And I'm going to do this. So you can see that I have a lot of your progress over here. So for example, if I pick one of the VSID here, and if I do this, basically this person has 6. Let me actually pick one that's actually a little bit bigger. Progress. Let's just pick one of the bigger one, this one. Okay, you can see that this is a one. So I keep each of the student has one of the file. And this student already finished. Let me see. How many finish is all the 11, all the 12, or the 13, 14. Okay, so this student finished this. So what I'm going to check is that I'm going to give the grade to see you at least have a 20 lines over here, then you can get that 20%. So for you to check, you just send me your VSID using either email or Facebook, and then I can actually tell you whether I have you on the record. Okay, and also when I reply to you, you will also have a record. I can actually send you that file so for you to keep a record, okay? Okay, I'm looking at, for the deadline for SP program, that is going to be due next Friday, not this Friday, next Friday. But for those of you who take incomplete, that you will be able to do a little bit even longer than that, okay? uh, the .hw6 update is actually going to be the executable from hw6 update.cpp. And hw6 search is going to from hw6 search.cpp. So those two are derived from hw6 client, not server. And they are going to talk to hw6 server. No, if you do take incomplete, you'll do final with me as well. So basically it's a homework 7. So I'm going to do the homework 7 with I will arrange a way for you to do that for the incomplete grade. Okay, I'm going to spend some time just talk about hw6 server.cpp, okay? So we have one question about server.cpp, one is about update, okay? So I think I will go with update first. I think update is probably easier. Okay, I'm going to use my HW6 client, which is I'm actually send it the first time I provide, because this program is really very close to HW6 update. Okay, in fact, I think my update is equivalent to this, except the last part. So when you go to the last part, this part is about search. So basically after this part, everything I'm going to comment out, this looks like almost like an update, almost, okay? So if you look at the program right before this line, Okay, right. This is from the HW6 client redacted.cpp. So before this line, I'm just read in the JSON file, the base input update 1 or base input number 2. Okay, so those JSON I basically process, and then I call this JSON to post to convert that to a post object. And I build up the RPC setup with a HW6 client. And then what I did here is just call the function, my client.update, my post dump J store. This is a line I'm just calling to the server. So this is the client side, is calling the server, calling the update function, and then get the result back. That's basically what the update is supposed to do. Of course, you need to look at the update version of the Homework 6 specification to see what need to be printed out on the server side, on the client side. If it's on the client side, then you need to make sure that whatever code you're writing. Okay, this is just a reference implementation. It's not complete. But this one is fairly close to HW6 update.cpp. Okay. All right, so I'm going to talk about HW6 server. That's the part that's actually the other student has a question. Let me actually just return this back to its original state. Okay, I do want to say that since I'm on this topic, I have seen some of the students who, wait a minute, why won't I indent this correctly? Oh. The indent of the code is actually very important because it help the programmer himself or herself to actually understand the structure of their code. So I'm going to go for HW6 server redacted. So this part is just similar to your homework 3 is fine, but the main issue is this two function, HW6 update and HW6 server. The other one is called search. Okay, so I'm going to just go over the update, and hopefully you can figure out the search yourself. Okay, so let me actually just go over this function very quickly. On update, is take one parameter. This is the update JSON is the JSON string that you receive from the client, where the code I showed you about a minute ago. So over here is easy. I just basically declare result JSON is this is the one I'm going to send it back. Okay, and I use this name buffer to either read or write to a JSON file. A JSON file has a format JSON, post ID. It should be profile ID, and then underscore post ID dot JSON. Sorry, the name is wrong. It's basically this is the file name to this file, post underscore. Okay. And then this is the file pointer to that file above, to the file above. Okay. Okay, so this is just declare some variable. So this part is just process that JSON. Okay. However, you notice that I already declared the object pointer here, post. This is a post object pointer. And then I have, this is a standard way for me to parsing the JSON. Okay, so then what I check is that you can see that now I'm checking whether this JSON I just received, whether it has ID. If it doesn't have ID, I don't need to do anything. It's not a JSON, right? So if it's the ID is okay, what I did is I first try to, let me see here, I try to actually print out the file name. You see the file name is the ID post, then ID underscore JSON. Okay. So once I have this ID, okay, here is a part that start to get interesting. The first thing is called postmap.find. So postmap.find, this is something you should know is postmap is a map, is an STD map. A map is a STD standard template library that's similar to vector, but it has a key value. So postmap.find, it basically the first thing, the parameter is the ID I just got from that field, because previously I already checked the ID. If your code can reach this point, means that that JSON must have an ID. So I will use that ID to actually try to find out whether this ID is already available in my the post map. So last time I used this particular slide. I want to actually use these slides again. Let me save it. Let me open. I think it's a 14. So this is a post map. Look like this. I think I talked about this Monday, probably Tuesday as well. So the post map you can see is an array. And basically I use ID, try to, if you do post map find ID as a string, it will return with one of the index value. So in this picture, my post map have a 7. And now, if it can find that, no, not 7, 8, from 0 to 7. If you can find that ID from this 8 element, it will return number 2, which is the index to this find member function call from postmap. That if, however, that this number is nowhere to found, then it's actually going to be number 8. It's going to return number 8, which is the same as postmap.end. So postmap.end is equal to 8. So that's why this particular line, which is equivalent to this particular line here, is basically check whether this particular post is already in memory. Okay, if it's in memory, then if this is not equal, you see, if it's not equal, it means that you already have it. So now you're going to update another one. So that's why it's a merge, because you already have a post. Now you have an update coming in. So you're going to merge these two together. Okay, but if what happened if this is actually equal to the end, that means it's equal to 8, then you're going to do this. You're going to do this. Now I redacted the code a little bit. But the first one you want to check is that whether there's a file for this post, whether you already actually, it's not in the memory, but it's the file. So in that case, you're going to open that file using the fname. Remember here, we have this fname buffer we created. You use that name to see if that file exists. If that file exists, then you will read it in, and then you are going to basically using JSON to post to convert that back to a post object, and then you do a merge. Okay, so let me write it down a little bit more here. If that, if the file exists, I will do a few things. Number one, I will load the file, and then JSON, JSON to post, yeah, JSON to post, which will generate a post object, okay? And then I can do merge, okay? Because now I have the object on memory, the original one, now I can merge that. Okay, that's case number one. Otherwise, this is not necessarily a merge. So I will just still I will call. I think I will call. I will still call JSON to post actually. I will still call if, which means that the object is not there. So I will call JSON to post from my v message, and then I will store that post to post star to the object pointer. Okay, so this is two cases that you have. All right, so this is this block. So if RC is small as 0, means that if anything goes wrong in the process, your return code need to be set to be -1 or any negative value. If there's no problem, then the RC is going to be 0. Okay, so this part is just return some error condition. Okay, so now up to this point, if your code still survive here, that means you already, everything is okay. And now you definitely have a post star, the object pointer in memory. And also you have either updated or merged with your object from that in memory. So now what you need to do is that now you need to write it back. Means that you want to write that object back to the file. Remember, you might have read it in, though you're going to write it back, okay? So I think I show you the code, how do I write it back? I didn't show you the code how to read it in, but I show you the code how to write it back. So you use the same name, the file name that you created, don't delete it, it's still there. fopen means to open the file. Now I call a post f pointer. And if it's not null, because sometimes fopen might fail. Fopen might fail means that I cannot open the file, I cannot read the file, whatever. So if this pointer is not null, then I'm going to do the following. So this few lines of code, I'm essentially printed. I write the file back to write the content as a JSON format back to that file. So this is the routine fwrite. I'm using this fwrite here, but I have to do a few things before that. So this piece of code is doing that, okay? And after I've done that, I close the file, okay? And then finally, if I'm done, then I just return, because I already have that object, which is post pointer. So what I did is I just call post pointer dump J. I dump J the whole thing and return the whole JSON string back to the client. So that's why you, at the client side, you are going to go get this. So you have a two-way. You can get one of the two output. One is you get this output from dump J, or you actually, if your RC is not equal to, is not greater than or equal to 0, you're going to get the status fail. This is a part if there's anything wrong. Okay. So that's the introduction to how you can get the server stuff to work. Okay. Any question? Yeah, it's due 11:59. You're right. Okay, we can take a look at the search part. The search part, I assume you're working on from the server side or client side. Okay, let's take a look at this. Okay, so this is a search, and the beginning is the same thing. We're just handling the search clause. So remember, the search clause is just the keyword. It's one keyword for the base one. And this part is just processing that JSON. So until this point, you already process the search clause JSON that you just received from the client. Okay, this part. So the first thing I did is I check whether you do have a keyword, whether you could send me a valid JSON, but this JSON doesn't have a keyword, which is really the keyword, which is really important for me to perform. So that's why if the keyword is equal to is not there, then I'm going to return -1, right? Okay, so this part is that the real action means that okay, now I have a keyword for me to do something, right? So this is what I did. I basically first I want to tell you what's the conceptual things you can do, and then what's the other things what you can do. Okay, basically we have a bunch of posts, and each of the posts has a pointer to a vector called keys. So each of the key is contain one keyword. So essentially, we want to look for every post that we have on the server to see if one of their key match the keywords I'm looking for. If we match, then we want to return the whole post to that, right? So of course you can do a search through the postmac to go through like an array that check the key for every single element. That's nothing wrong with that. It could be a little bit slower, but I think that's a perfect way to do that. In the reference implementation, however, I did somewhat differently. I have this concept called OKey. So what is OKey? OKey has, let me actually write it down. OKey has two elements, at least two member, which is important. The first element is actually a keyword, which is a string, which help us to match with this. And then I have the second one is actually a post. I will call this, it's a vector. It's a vector of post star. Okay, so it has two elements. The first element is the keyword. The second element is it's a vector about all the pointer to the post. So essentially, I'm using this data structure OKey to do the following: that I actually append or push all the post pointer that has this keyword into this vector. Okay, so essentially what you have is that you have a bunch of keywords, and each of the keyword associated with all the posts already. So I don't have to search the post map anymore. I just need to search all the OKey I have. That if I have a OKey, which is contain the keyword similar to the one you're going to search, then I'm just very conveniently, I just pulled out that vector, the second member, and use that to construct a reply for the search, okay? And of course, how do I actually search for this keyword? How do I actually search that which OKey that I match? Then I actually use this one. I have something called, let me just look at whether I have JSON post here. Yes, I do have. You see here, I have an OKey. I define another map called allKey, which is has the matching is the string and it's an OKey pointer. And then I provide the two functions to do that. One is get OKey, one is get post by key. Okay, is related to that structure. So I'm going to use this pointer, use this slide to represent the allKey. Let me just do this very quickly. So this is a post map, but I'm going to change to, I call it allKey, because they're both map, okay? I'm going to get rid of this because this is unrelated. This one is unrelated. And this one is unrelated. I'm going to get rid of that. So over here, this one is keyword, okay? And over here is pointer to the vector of post star. Okay, so now I have another key map. Now the first one is a keyword, the second one is a pointer to a vector of post star. So meaning that, let me see if I still have this thing here. I still have that slice here. Interesting, I don't have, I didn't put it here. Okay, I will just use this one. So this one is a pointer to a vector, which contain all the posts that are associated with the keyword. So now the keyword, of course, is not like this. This is ID, but here the keywords like ECF36B is a keyword, and this key could be, this keyword could be Patrick James, and this keyword could be just Oracle, and this key could be C++, for example. Okay, so I'm going to get rid of this because this is unrelated. So this is a structure about ORCID, which is a STD map. Okay, just to let you know, this is a STD map. Map has two parameters. One is type for key, type of key, and the second is type of any kind. Okay, so this is basically the map has two instead of vector only have a one. Okay, so in other words, if you understand this part, then when you give me a key, I'm actually going there to search whether that particular key you just provide has an entry. Once you have an entry, assuming that key is ECF36B, as we see that in the example, make it a little bit bigger. And then basically this pointer is what I'm interested, because this pointer is pointing to all the post object pointer that has that key. And therefore I'm going to return the JSON array which contain all the posts that are pointing by this particular pointer. So that's why the search is doing like this part. Okay, sorry, I have to go over here. Let me just check whether I have to do some. Okay, similarly, that this part is RC is a minus, is a negative value. I'm going to say status fail. If it's not fail, I'm going to return the result JSON, which means that in this code somewhere here, I have to take out all the posts from this pointer and put them together as an array of JSON post on that result JSON, and then I can return it correctly. Okay. Any question for that?
Could you give us like a slightly like maybe pseudocode, like half real code way of like indexing the OKey map? Because like for a vector, you just throw in like a number. You had like a loop going, just like you put the I in there. I've never like used like something like an OKey map, so maybe some help on that.
Sure. Give me a second. Let me take a look at that. I heard you, Manuel. I just want to say, for Jenny, it is which post, but it's which posts. It could be multiple posts have the same keyword. For Aldo, you're asking when and how we each post include a keyword to be added in the OKey map. I did that when I processed the keys. So let me go to Aldo's question first, and then I will go back to Manuel's question about how to do that part, okay? I'm going to share my screen. So Did I have that in JSON? Let me see if I have this already. No, I didn't have it here. Oh, I know what I have. Sorry, I have it on a different redacted version. That the new redacted version I upload. I think I have it here. Let me just take a look. Okay, the new redacted version even include a key already. Okay, include how do I handle get post by key and get O key. Okay, take a look at that as well. But I actually give also more information on the JSON post comment. Oh, I didn't have that part. Okay. All right. So now I'm going to unshare my screen to show you a little bit. I think it's okay to show you this part, but I want to. Okay. So for Aldo and others, this is the part how I implement the keys processing, this part. Okay, so refer to your question, Aldo, what I did is this line is going to make a difference. See, what I did is, so for all other things that we actually did this part, right? We always push the pointer into the my posts attribute. But you see that I'm actually also doing this here is that I look at the OKey pointer for that keyword that I have, and then I push my post pointer into that as well. So over here, I actually search because over here, I'm handling the key, right? So I'm actually using this function get O key. When you have the key, you extract from the update. This is JSON post that you know that what key you're interested. So I'm actually using this. I obtain the O key pointer. And where's get O key? Get O key is from the beginning of this file, which I have that O key using the get O key. And then this give me the O key pointer, and I basically just push back the post into that. So essentially what I'm doing is the O key is each of the entry is an O key pointer. And when I do the push, I'm actually adding something at the end of this vector. Okay, so that's how I be able to update the vector for all this posts associated with the key. That's just one way. I want to clarify, this is just one way to do it. There are multiple ways to do this, okay? Does that sound okay, Aldo? Yes, these two lines are actually pushing into two different vectors. One vector is actually related to the post itself. One vector is related to all key. So one vector is for the post to remember who are my keyword, but the other vector is really looking at, well, I want to maintain which post related to that, okay? All right, so now I'm actually going back to, how do we iterate through the map? You can just using the index. So you can see here is that, let me show you earlier. Okay, if you take a look at here, this postmac find is going to give you the index, right? This is going to be the index that's you're going back. So I want to do this, assuming this is not equal to this. What I did is just like this. I can do, assuming I do this, integer I is equal to okay, so this one is postmap find, right? In my example earlier, say this is actually going to be equal to 3, say this, okay? So if you enter the key, you say postmap find is going to return you the index. And then what I can just do is postmap 3. Or I can just say postmap I. Okay. In fact, when you write a loop on postmap, usually you do like this. Sorry, I want to get rid of this. Let me actually tell you the code you will write for looping through the postmap or any map. Okay, this is just an example. You say for I is equal to 0, I is smaller than postmap end, and then I plus plus. And then inside here, you do postmap I blah blah blah. Okay, that's the way you can iterate through the map or any map or postmap or key. You can do that. Does that sound good? Okay. So, are there any other question before I go to Manuel's question? Yes, yes, that's right. I mean, if you look at this, that's why I show you here. If you have an A element, the index is 0 to 7. So postmat n is actually point to A. So postmat n is like you can think about how many, the number, either the index right after the last element, or you can say the number of element in the post. Yeah, that's what postmat n is trying to do. Okay. Okay, so I guess what Manuel, you're asking how do we actually do the search part using this graph into the code? Is that what you were asking?
Yeah, I was also kind of asking what you just answered for like the indexing through it.
Okay, all right,
Both.
that's fine. In fact, I think in my code, I might not even need to indexing through. Let me actually just check what I did, okay? I mean, there are multiple way indexing through is nothing wrong with that, but I'm just, remember, I didn't actually even need to indexing through for this purpose. Let me pick through my own code a little bit. Yeah, okay. I don't want to show you the code, but just give you a sense that I use get post by key to obtain the pointer to the vector of posts, that's actually belong to that key. So that's why I call get post by key. It's really getting a vector of post pointer. And then so I have the vector of pointer, which each of them is a pointer to a post. Then I iterate through that vector, not the map, but through that vector to reconstruct the post from the C++ post object to the JSON string using dumpj, the post dumpj. And then I basically insert that into an array of JSON, which that's result.json, result underscore JSON. And then after I've done that, then I can send the whole thing back to the client. Okay. Any question? So map and vector is really similar. It is a vector. Map is a vector, but you can think about this is the idea of a map. And so if you have a vector, the vector just this part actually, this is a vector. If you think about that, this is a vector. Oh, you cannot see my screen. I haven't shared my screen. Let me share my screen. I want to change the color, sorry. So this yellow part you can think about as a vector, right? It's a vector of this and without the key. So you can still use index and you can still use push, whatever, but you just don't have the keyword associated with that. So map is basically have the second element has a key. So if you change this word to vector from map, then you only have a one argument you need to provide within this small than and bigger than bracket. But if you use map, then you have to have the key, which is a string to allow you to specify what is the key for me to match with the. So I basically allow me to match, not just because the regular vector you can only access to them through the index, whether it's a 0 element, first element, to just like an array. But now map actually provide you an extra help that you can directly using the keyword to search for the element inside here. So that's the only difference between map and vector. Okay. Pretty much. Yeah. Alexis is the same. Yeah. Iterating through a vector is the same as map. Yeah. You use the same index scheme. Yeah. Okay. Any other question? Okay. The way to make JSON result JSON to be an array, it will be similar when you do dumpj. It's the same way you do a dumpj in the array. So instead of show you the code, I'm going to show you the dumpj code to see how you can make an array. For example, I'm going to show you the dumpj for comment. So in comment, that one of the elements in the comment is reaction, right? The reaction. So reaction it has a multiple reaction, and we want to, when we do dumpj, we want to build a JSON array that contain multiple reaction, right? So this is piece of code when we did the reaction part within comment. So let's see what happened. The first thing I check whether reaction is null. If it's a null, I'm not going to do that. If the size is equal to 0, I'm not going to do that because there is no reaction. So once you know it's not null, it has a size greater than 0, I'm going to start building that array of JSON. So let's see what I did. This is exactly the same way. So first I create a loop, go through that vector, okay, using size. And then what I did is for each of the dump JV PTR, I call recursively this reaction I to the dump J. So I call the lower level. So if this is going to be the search, you're going to do, this is probably going to be an O key, whatever pointer, and this is going to be this post, that particular pointer, each of them, you're going to do dump J. And once you do that, you actually just write this to this array. You see that JSON-C creation array. I'm going to write to that. This one is actually the array I declare here. And then I'm actually, each of this I'm going to define. And then I did a, where did I do that? And then this is the array I have to do. Wait a minute, where did I do? Yes, okay. You see that this is a JSON reaction, which is array, and I just insert the index into each of this. And I is, as I increment, I'm going to increment as well. So essentially, JSON-C reactions is building up this array in the JSON format. Okay, it's not in the C++ format, in the JSON format. And when I did that, then I basically create an array. The data is going to be JSON-C reaction, and the count is going to be the size of that array. Now I actually have that. So this is a way for me to build up the array of JSON. So here I'm showing you, I'm actually concatenate different reaction object together into a reaction array. But similarly, you can concatenate an array of post object and into a JSON post array. Okay. So take a look at the code and see if you can get that part, okay? Well, result JSON will be an array. Yes, will be array that dump J, but yes, I would say it is correct. Yeah. Yes, that's what my design is. I let this is a question to Gavin. Yes, in my design that the all key you cannot directly access, but in C program, if you say extern, if you say extern std map all keys, you can access that as well. Because I didn't declare this as a static variable; it's just a global variable. Okay. So all key is a global variable, and the linker will be able to link it if you actually define extern. Okay, so I'm going to, if there is no question, I'm going to end this session and upload the pointer, okay? Yes, I will holding my office hour tomorrow and Monday as well next week, the whole week. And also, in fact, I have a one-to-one office hour right after this. I kind of want to end this because I told one of the students to start with me at 3 o'clock. I think that student might be one of you. I'm sorry about that. But yeah, I'm still holding one-to-one office hour and also the regular office hour. Yeah. For those of you who are actually going to do incomplete, I'm going to probably do the same thing as well. So you can still make me make a one-to-one appointment with me. Okay, that's fine. All right, I'm going to close this, and then if you have one-to-one meeting with me this afternoon, you know I'm going to delay by about 25 to 30 minutes. Okay, I'm sorry about that. All right, good luck, and let me know. Okay, thank you. Bye.